Okay, so let's look at one more question like that. This is number 6. I forgot my pen today, so the writing will not look so good, but you'll be able to see. Can you see, or do we need to switch off the lights? Okay, so for number 6, we want to integrate sine mx cos nx dx. So this is what we are given. So we said whenever you have a product like this, you must rewrite it as using one of our identities. So when it's sine and cos, the identity is half. Sine and cos, we know we get it from sine a plus b and sine a minus b. So here, what we will be integrating is there's a half here, and then sine a minus a plus b minus sine a minus b dx. There's an x there, dx. Okay, and then that is the identity we'll use, except here instead of a and b, we have m and n. So m and n, please keep your mask on the whole time. So instead of a and b, here for engineering math, so instead of a and b, we just replace them with m and n. So it's like m and n. Okay, so like I said, I forgot my pen today, so the writing is not very good. Okay, then from there, what you do is you need to separate them or take the half outside. So you'll have sine m plus n x dx minus half, the half obviously is outside, and then sine m minus n m minus n x dx. Okay, so what we are integrating, this is a half the integral of sine m plus n dx. There's an x there. And then plus okay, so that is what we are now integrating. And we know how to integrate sine m plus n x. So the half will be outside. So this is just a half. And then the integral of sine is minus cos. So we have minus cos m plus n x, and then we divide by the derivative of m plus n multiplied by x. So it's like this, and then we divide by m plus n. That's the integral of the first one. And then the second one is the same thing. We have a half outside, and then the integral of sine is minus cos. So we have minus cos m minus n x, and then we divide by the derivative of m minus n x, which is just m minus n. Okay, and then you can simplify it, maybe multiply the half and the m plus 2, sorry, the m plus n, and the same thing there, or even factor out the half altogether. That is fine. Okay, I think that is pretty simple and straightforward, isn't it? Your mics are not muted now. You can say something. Is it fine or not? Okay. Okay. Then the next type of integrals that we look at are integrals that involve powers of sine and cos. So we'll be so these are integrals. Thank you. Integrals of the form, so we have sine nx dx. Okay, so here, this is what we're integrating. It's sine of x raised to a power. And for this type of questions, m and n will be either even or odd numbers. So depending on what m and n are, whether they're even or they're odd, we work it out in a particular way. So when n is even, so when n is even, what we need to do is use this identity, which I'm sure you know, that sine squared x is equal to,
Mom.
I don't know what
Mom.
happened now.
Okay.
Okay, so we use this identity that sine squared of x is equal to a half 1 minus cos 2x, and cos squared x is equal to a half 1 plus cos 2x. So I hope you remember this identity from last semester. So depending on what n is, you have an even power. This is the identity you must use. And I'm sure you can see that integrating this is very easy because I can just multiply the half out. So I have half minus a half cos 2x, and the integral of cos 2x is sine 2x divided by 2. So that's easier to integrate than what we have over here. So that is when n is even. Then when n is odd, we use sine squared x plus cos squared x is equal to 1. So that means you may have to rewrite your power using this identity. And with these questions, you have to do a lot of practice really to get the hang of what it is you need to do. For some questions, they look similar, but the way you do them or approach them is not necessarily uniform or the same. So let's look at some examples of how we do that. Number 1, we have the integral of sine squared 2x dx. Somebody has a question? No. Okay, so here our power is even, and we said when this is even, we can write it as using the double angle identity, of course. So sine squared 2x, we know that this is equal to the integral. We have a half outside, and then 1 minus, because it is sine, and then we say cos, and then the double of that angle. So this is cos 4x dx. Okay, so I'm using the identity, the double angle identity, to rewrite this. Then you would multiply out your brackets. So I have the integral of half minus a half cos 4x dx. And then the integral, I think I forgot a c here. I'm just remembering now. There's a plus c there. Okay, so now we can integrate. What is the integral of half? What is the integral of half? It's, yeah, what is it? It's the same. C. The integral of half is not C. What is the integral? Erastus, or is it Erasmus? Your mask must be on the whole time. What is the integral of half? Half x, or x over 2. So this is x over 2. And then I must integrate this one here. The negative will still be there, so it's negative half. What is the integral of cos 4x? It's? Okay, so this is sine 4x divided by 4, and then you add a constant. Then you can multiply the half and the sine 4x over 4. So we have x over 2 minus sine 4x over 8, and then you add your constant of integration. Okay, so when your exponent is even, try using the double angle identity, and then you see that what you have after you use it is much easier to integrate than what you started with. Number 2, we have the integral of cos squared 3x dx. So again, here our exponent is even. So in our mind, we should already be thinking, I need to use the double angle identity. So the double angle identity is the integral. I have a half, then it's 1, it's plus because it's cos, and then cos of 2 times this angle. So that is 6x, and then dx. So you'd have to then multiply out your brackets or take the half out and then integrate. So this is the integral of half plus a half cos 6x dx. And then we integrate each of them individually. The integral of half is x over 2, or half x. So I have a half x. And then here I have a half, the constant. The integral of cos 6x is positive sine 6x divided by 6. So this is multiplied by sine 6x over 6. Then you add your constant of integration. Okay, then we can rewrite this. This is x over 2 plus a sine 6x over 12, and then we have our constant of integration. So don't forget the constant of integration. In the test, you will lose marks if you don't write it. So make sure that you do, in fact, write it. Question? Then the integral of sine to the power of 4 of x over 2 dx. Okay, so here our exponent is even. So it's 4. Usually when it was 2, then you can just use the double angle identity. So with this one, what we need to do is first write it as a square. Okay, so we rewrite this as the integral of sine squared of x over 2 squared dx. Because this one here in the brackets is the one that I want to break down using the double angle identities. Okay, and then make sure that your exponents here, when you multiply them, you are back where you started. Okay, then the one on the inside, that is the one that we would break down using the double angle identity. So I have the integral of half 1 minus, because it's sine, and then cos 2 times this angle over here. So I say x over 2 times 2 is x. So this is cos x, and then I square it. So here, what I have in the square brackets is sine squared of x over 2, and then I still have to square it because of this 2 outside there. Okay, then here I can multiply out my brackets. So I have the integral of a half minus a half cos x to the power of 2 dx. And still here, integrating this with the square over there is not that easy, so multiply out the brackets. So we know how to raise a binomial to the power of 2. So this is half squared, which is 1 over 4. And then half times negative half cos x times 2, which is negative a half cos x. Okay. And then minus a half cos x squared, which is plus 1 over 4 cos squared x, and then we integrate with respect to x. So now all the parts that I have to integrate, the 1 over 4, easy to integrate, is just x over 4. The half cos x, easy to integrate because the integral of cos x is just sine x. And then cos squared of x, this one I have to rewrite it again using the double angle identity. So what I have is this. So I have the 1 over 4. Sorry, I'm missing my integral. So the 1 over 4, I have to integrate that. Then minus a half cos x. And then this 1 over 4 cos squared x, I write it, the cos squared x is the one that I rewrite as a half 1 plus cos 2x. So I have a quarter, and then the cos squared x is a half 1 plus cos 2x, and then this is all with respect to x. Okay. Yeah.
Why are we putting 1 over 2 instead of 1 over 4?
Is it 1 over 4? Yeah, it's 1 over 4. Okay, then we can just multiply everything out with the last term and then integrate. So here, the integral of 1 over 4, we say this is x over 4. And then minus a half cos x, the integral of that is minus a half sine x. Okay, then keep in mind you need to multiply like that. So you have 1 over 4 times a half times 1 is 1 over 8. And the integral of 1 over 8 is x over 8. And then again, I have 1 over 4 times half times cos 2x. So that's 1 over 8 cos 2x. So here I have 1 over 8. Then the integral of cos 2x is sine 2x divided by 2. Then we add our constant of integration. So any like terms that you have, you must collect them when you simplify. Here I have 1 over 4 and x over 4 and x over 8. Can add them together. That is 3 over 8. So we have 3 over 8x. Then the half sine x has no like terms, so it stays there by itself. And then this 1 over 8 and the minus half, okay, the way I wrote it there. Okay, the 1 over 8 and the sine 2x over 2, we multiply them. This gives us sine 2x over 16, and then you add your constant of integration. Okay, so sometimes you will have to use the double angle decomposition more than once, but that is not a very big deal. Where's that? And number 4, now we look at when we have an odd power, dx. So when you have an odd exponent, what you should do is try and break it up so that you have an even power and multiplying by something with power 1, maybe. Or try and use the even power way. So this sine to the power of 3 of x, we can write it as sine squared times sine x. So this is the integral sine squared of x multiplied by sine x dx. Okay, and then this one, the sine squared of x, I use the identity sine squared x plus cos squared x is equal to 1, and that means sine squared x is equal to 1 minus cos squared x. So I have the integral 1 minus cos squared x times sine x dx. Then I multiply inside the brackets. This is the integral of sine x minus sine x cos squared x dx. Okay, the first term sine x, very easy to integrate. The integral is minus cos x. And then over here, you should notice that I have a function and its derivative. So I have cos to the power of 2, and the derivative of cos is minus sine. So here I can just use the substitution method to integrate that. So here, the integral of sine, we say it is minus cos x. And then here, what I will have is cos to the power of 3 divided by 3. Your mask, please, your mask. Don't take it off. I also want to take mine off. Plus cos to the power of 3 x over 3. And then you add your constant of integration. So you can try differentiating this. See, the 3 will come down. It'll cancel with that one. I have cos squared x, and then the derivative of cos x is minus sine x. So I will have exactly this. Okay, so that was the point of breaking it up like this, rewriting it using our identity, and then from there, noticing that with this one, this is the derivative of what we have over here. Okay, you can rearrange it so that the positive one comes first, but it doesn't matter. Leaving it like this is also perfectly fine. In number 5, we have the integral of cos to the power of 5 of 2x dx. So with this one, we want to do the same thing. We can rewrite this as cos to the power of 4 of 2x multiplied by cos of 2x. And then that cos to the power of 4 we would write it as cos squared to the power of 2, and then the cos squared, we would break it down using our double angle identities. So this, you rewrite it as cos 4 2x cos 2x dx, and then this to the power of 4, we said it's cos squared squared. So this is the integral of cos squared 2x squared, and this is cos 2x dx. Okay, I said we must break it down using the double angle identities, but that won't work. So here I'm not going to break it down to the double angle identities because that will change this value over here, and when I multiply them, you won't have the derivative of the other one. So it's best to rewrite this as 1 minus sine squared, so that when I multiply, I have sine times cos, and then I can use substitution. So this is the integral of 1 minus sine squared of 2x squared, and then cos 2x dx. And then we can multiply out our brackets. This is the integral. So first, the one that is being squared, this is 1 minus 2 sine squared 2x plus sine to the power of 4 of 2x, and this must multiply with cos 2x dx. Okay, so when I write it like that, it's better because when I multiply, I'll have sine and cos, then I can use substitution to integrate. So multiply, we get cos 2x. We know how to integrate that one. That is just sine 2x over 2. Here, when we multiply, I have sine squared 2x cos 2x. So you can see cos 2x is the derivative of sine 2x. So this will just be sine to the power of 3 of 2x divided by 3. And then you still multiply by this 2 here. And then the same thing over there. So when we multiply out the brackets, we have cos 2x minus 2 sine squared 2x cos 2x, and then we have sine to the power of 4 of 2x cos 2x. This is all with respect to x. So we say the integral of cos 2x, this is sine of 2x divided by 2. Then here, this is just sine to the power of 3 divided by 3. We still keep the 2 there because this cos 2x is the derivative of sine 2x. So this is minus 2 over 3 sine to the power of 3 of 2x. And then the same thing over here, the derivative of sine 2x is cos 2x. So you just say sine to the power of 5 of 2x divided by 5. So this is sine to the power of 5 of 2x divided by 5. And then you add your constant of integration. Pretty simple to do, isn't it? Is it not? Or is it difficult? You guys can talk, right? Not really. Yeah? More. You were saying? Or it wasn't you? Yeah, what? I can't hear you. Why? Why? I must go to the IT people to fix it. Okay, let's look at some questions from exercise 4.4. Exercise 4.4. We look at question 7, 9, 10, and 14. So we start with question 7. So this is the integral of sine squared x over 2 dx. Here I want to see how you guys do this one. So I will give you 2 minutes. Let me see how you do it. Did we all sign the register? Okay. Okay, if you're done, let me know so I can see what you've done. Are you done? Done. Okay, so let's do that one. So you must know the identity. So right now in class, you have your identities with you. If you've forgotten everything we did last semester, you must go find those notes and bring them to class with you, because I'm seeing people have forgotten their identities. And in the test, even if you know what to do, but you don't know the identity, you will get everything wrong. So here we said you need to rewrite this. Because it's sine squared, you put a half, and we use the double angle identity. So this is 1, it's minus because it's sine, and then you multiply its cos here. You say x over 2 times 2, which is just x, and then dx. This is the identity that you must use. I'm seeing some people have sine here. Some have sine to the power of 3. I don't know how. Okay, so get your identities correct. So here you can take the half out. 1 minus cos x dx, which is a half x. The integral of cos is sine. So we have a half sine x plus c. That's it. Okay, next one is number 9. Still in the same exercise. Number 9, where's number 9? The integral of sine to the power of 3 of 2x dx. Can we take 2 minutes to do this one? So you need to remember what I did when I had sine to the power of 3. You must break it down, and usually the way you break it down, you want sine and cos next to each other because one is the derivative of the other, and then you can use substitution to integrate. You done? Okay. Integrating will affect it. So it's not just cost 2, it's divided by 2. Okay, so we need to look at and here 1 divided by 2. If I have x squared and I integrate x to the power of 3 divided by 3. So here the number at the top, the exponent must be the same as what is correct. Okay. Yes, that's good. That's good. That's good. Okay. There was a sign and then is and I see that in the test, I wonder what happened. How? And here it's No. On the test, I'll just circle it and put the question mark. I will not give you mark. I don't know what is happening here. Here, what you cannot say you just integrated this one. What about this one? You didn't integrate it. You must use substitution to integrate. So with integration, and you're integrating a product, you just integrate the first one. No, use different techniques like parts, whatnot, substitution, but not like that. So the first part of what you did is fine. You just need to fix the way you integrated that one. Anybody else? On this side, what is happening? Yeah, using get to 2, so that 2 outside. I must fix it. And always, you can always, after you get your answer, differentiate it and see if you get back to what you started with. That's why. So that even when you multiply the so that's not the way to go. Try the other way. I would say, hey, the way you look at this. Now this sine squared using sine squared plus cos squared is equal to 1. Okay, let's look at this one. I'm seeing, when I say, are there any questions? Everyone is quiet, their mics are muted. But when I walk around, I can see there's some serious problems. The what? The data, or what? No? Okay, so let's do this one, because when you break it down, we have basic, simple integrals, but people are still struggling with those. So that is not what you should be struggling with. So we have here, the way you must break it down is sine squared of 2x, and then sine of 2x dx. And then this one over here, remember there are 2 ways to break it down. You can break it down as with cos 4x, or sine squared plus cos squared is equal to 1. If I were to use cos 4x and then I multiply, you would see that I don't have the function and its derivative multiplying, because I'll have cos 4x sine 2x. They're not derivatives of each other. So what I need to do is this sine squared x, I must rewrite it as 1 minus cos squared 2x. So this is the integral 1 minus cos squared 2x sine 2x dx. Now we multiply out our brackets. Integral of sine 2x minus sine 2x cos squared 2x dx. Okay, integral of sine 2x, this is negative cos 2x divided by the derivative of 2x, which is 2. So don't forget that divided by 2. I've been seeing people forget that. And then over here, this one, you must use your u substitution. If the way I'm doing it here without writing u is equal to this, du is equal to that, and then substituting is confusing, write it down. Let u equal to this, du is equal to that, then you substitute. Then here we can see that this, I have u to the power of 2, and du is minus sine 2x. Okay, so what I would have to do is u to the power of 3 divided by 3, and then I also need to divide by 2, because this is not just sine of x, it's sine of, well, let me do it this way so I don't even, the only thing missing here in order for this to be the derivative of cos 2x is a 2. There needs to be a 2 outside, so I need a half. So here, my integral, I said I need a half, so I say plus a half cos to the power of 3 2x over 3, and then plus c. Is that, I think some people wrote something different, but I said what they have is correct. What number is that? I think, I don't know if anybody got this, but I said they were correct. If I said you were correct and you didn't have this, you were actually not. Okay, I think you were correct up until this point here. My bad. Okay, so what I said is, or how I did this one is, you can see that the derivative of cos 2x is negative 2, so I need a 2 here. If there was a 2 here, then it's the perfect derivative of cos 2x. But I can't just add a 2, then I've changed the question. So what I need is, I need a half here as well. Then this part here is now the integral here, and then this half is that one over there. Okay, so your answer should actually be what is it? Negative cos 2x over 2 plus cos to the power of 3 of 2x over 6 plus c. That is that what you got? You have a question, yeah?
Yes, it's an example we did the same mistake.
Which one? What was it? Which one?
We did the same mistake. I just don't know which question is
Ooh, yeah, then you'd need to fix that. Ooh, I think even this one here. Is it this one? Yeah, even this one, number 5. Yeah, because the derivative of, yeah, we need a 2 outside, and then we need to divide by a half. And what did I do? Let's see what I wrote here. Okay, that one's fine. Okay, yeah, even this one here, there should be over 10. Because when I differentiate this one here, the 5 will come down, it'll cancel. I have sine to the power 4 2x multiplied by sine of 2, the derivative of sine 2x, which is cos 2x, and then the derivative of 2x is a half, is 2. So I need, this should be over 10. Is that what I wrote here, please? Sine squared the 5. Yeah, that should be over 10. Let's see. Okay, if I differentiate this one now, the 5 comes down, I have a half, then cos 2x multiplied by 2, the 2 cancels, yes, okay, so yeah. Okay, we can do one more very quickly. Number 10. Yo. Number 10. I'll look at those ones and then correct them. Okay, number 10, we have the integral of cos to the power of 3 of x over 2 dx. And we quickly do this one. Okay, let me check the ones that I corrected. Okay, this one is fine. Okay, this one is, okay, this one is fine. It's 3x here. Okay, this one is fine. Okay, so it was only example 5 that was not correct. So with example 5, make sure that you change the last part. It should be sine to the power of 5 2x over 10. Okay, we'll continue tomorrow.